Welcome to Crypto 101, a first principles jargon-free course on blockchain and its impact on financial services. We are in the process of learning how cryptocurrencies mimic the properties of fiat money. In the previous lesson, we learned about the role of blockchain addresses in holding the value of cryptocurrencies. In this lesson and the next few lessons, the property we will learn about is how Bitcoin accounts are secured for the benefit of the authorized account holder. To facilitate our understanding, we will compare security of assets held in a bank account versus a blockchain address. In the previous lesson, we covered the first of the four properties of fiat money, namely its storage in segregated accounts. In this lesson and the next few lessons, we will cover how these accounts are secured, similar to how passwords and PINs secure bank accounts. To help our understanding of Bitcoin account security, it is helpful to pause and reflect on blockchain addresses and compare them with bank accounts. The similarity between bank accounts and blockchain addresses lies in the fact that they are both identifiers used to segregate and track value of currency holdings. You can say that on a given day the unspent amount of US dollars associated with bank account X was 100 while the unspent amount of Bitcoins associated with blockchain address Y was 100. In actuality, blockchain addresses can hold other types of crypto tokens apart from currency, hence they are more versatile than bank accounts. But for now, we can ignore that nuance. There is a subtle difference between how banks' accounts are secured versus blockchain addresses. The bank account is akin to a password-protected file. You cannot even open the file without knowing the password. The blockchain address, on the other hand, is analogous to a read-only file, whose contents are viewable by anyone but editing the file requires knowledge of a password. When we think of a bank account, we visualize a digital version of a locker. You need a key in the form of a password or a PIN to unlock it. When we wish to transact with our bank, we send our bank a message. There are three types of messages that we send: inquiry messages, service messages, and payment messages. Next, we will look at what these are. In an inquiry message, we wish to view balances, statements, and transaction history. In service messages, we ask our bank to perform some administrative step like reset our password, update our address, or email. A payment message is a message by which we instruct our bank to make a payment on our behalf. The instruction may be delivered in many ways. For instance, we could write a check or swipe our debit card. Banks fulfill the request embedded in the messages only when the account holder can unlock the account with a password or PIN. In the Bitcoin world, an inquiry message is open to all. I can go to blockchain.com and search for the transaction history associated with any Bitcoin address. There is no lock on a blockchain address with respect to an inquiry message. It is visible to all. Hence, this is a significant point of difference with bank accounts. This website is an example of a block explorer that allows us to explore the transaction history of Bitcoin through a web interface. In the Bitcoin world, there is no real counterpart to a service message. The reason is that the Bitcoin blockchain network is minimalist. It requires little in the form of identity information from the account holder. There is no account level maintenance required since there is nothing to maintain. Later in the course, we will learn about intermediaries who make it easier for non-technical users to interface with Bitcoin. Using such intermediaries results in the need for maintenance of the kind seen in traditional banking. Understanding the payment message in Bitcoin is crucial to understanding how Bitcoin account security works. But first, let us spend a little more time on payment messages in banking. A payment message includes information needed for transferring money from one account to another. It can include attributes like the source account number, the destination account number, the beneficiary name, and the payment amount. Sometimes, the entire payment message is written out by a payer. For example, while writing a check. At other times, parts of the payment message are populated by the beneficiary. For instance, when we pay in-store or online with a card, the payment amount is provided by the beneficiary. In a card payment scenario, the destination account number is also populated by the beneficiary. For instance, a merchant's card reading machine is mapped to a destination account, even though it is not visible to us. In a direct debit, the entire payment message is created by the beneficiary. To create a payment message, we need an instrument. Examples of instruments include cards, paper checks, and online banking. The distinguishing feature of bank account security is that to create a payment message, the payer usually needs to log in to her account. The login may be in the form of a username and password for online banking. It may be in the form of inserting a debit card on a card reader and entering a PIN. The card reader is connected to the systems of the paying bank via the internet. Based on what we discussed so far, we can posit that payment instrument in banking performs two functions. First, it allows us to create a payment message on the basis of which banks know which account to debit and which account to credit. Second, it also allows us to log into our account. Another way of saying this is that the payment instrument enables us to prove to our bank that we are the authorized account holder. Identity authentication and payment message creation usually occur in close proximity to each other in the world of fiat money. Note that I use the word usually. That is because there are exceptions to this rule. Next, we will explore one such exception. When we use a paper-based payment instrument, we don't need to be logged into our bank systems. We can write a check with a pen. The creation of the payment message can occur offline. The equivalent of logging in within the check world is the verification of the user's wet signature when the check reaches the paying bank. To understand payment messages in crypto, it is useful to begin with a blank check as an analogy. Imagine a digital image of a check which has placeholders but no information on it. I enter a destination blockchain address, a source blockchain address, and the amount to be paid. These attributes represent my payment message. However, this message has to be signed with something called the digital signature. I will cover digital signatures in the next lesson, but for now all we need to know is that it performs a similar function that a wet signature on a check does. It is a proof that the person sending the crypto payment is an authorized account holder. I don't need to be logged into anything for creating the payment message and the associated digital signature. Now, I take this payment message I have created along with the associated digital signature and submit to the blockchain network. The submission of the payment message to the blockchain network is analogous to depositing a check to the banking system. When I deposit a check, the check is sent by my bank to the payer's bank and the payer's bank verifies the wet signature. Similarly, when I submit a payment message to the blockchain network, the digital signature is verified. Anyone can take two blockchain addresses, a source and a destination, and create a payment message, as well as attach a digital signature to it. However, if the associated digital signature is not valid, the message will not result in transfer of value. How is a wet signature verified? By comparing with a specimen signature. Who verifies it? A bank employee. Hence, the question arises, how is a digital signature verified and who verifies it? We will cover this in the upcoming lessons. For now, it is sufficient to know that the digital signature is verified by the people who are running the computers on the blockchain network. We will discuss later in this course on why these people perform this service. But for now, our focus is on the mechanism through which the digital signature is created and validated. We will dive into the how question and address the who question later. We can now summarize the differences in the account security framework between bank accounts and blockchain. Obtaining data from bank accounts requires security credentials while transaction history of blockchain addresses is public. Banks maintain many qualitative details about the account holder. Services requests for maintenance of such qualitative data requires security credentials. In blockchain, there is no analog of service requests since no qualitative data is tracked. Finally, creation of payment messages associated with a bank account, usually, requires near concurrent input of security credentials. The security authentication for transactions associated with blockchain addresses is decoupled from payment message creation. If we now elevate up to 50,000 feet, we can observe a foundational distinction between account security for bank accounts and blockchain addresses. The source bank account behaves like the digital version of a physical locker. The source blockchain address, on the other hand, is just a piece of metadata assigned to a crypto transaction. Anyone can create a payment message on the source blockchain address, but no transfer of money will occur if the attached digital signature is not valid. The takeaways so far are the following. A payment message is a message that spells out the instructions necessary for making a payment. The payment message in Bitcoin needs to have a digital signature associated with it. The payment message and digital signature can be created in an offline mode. However, for value to be transferred from the payer to the beneficiary, two things need to happen. 1. The transaction must be submitted to the blockchain network. 2. The digital signature must be verified. The verification of the digital signature is done by people who run the computers, called nodes, on the Bitcoin network. These nodes run software programs that verify the digital signature. We just summarized what we learned. But it is also useful to summarize the questions that still have not been answered. First, how is the digital signature created? Second, how is the digital signature verified? 3. Who verifies it and why? We will cover these in the upcoming lessons. This brings us to the end of this lesson. Review the summary of this lesson before proceeding to the next one.